Hello. In this video, we'll be discussing conditional probability. So to help motivate this, imagine that I have 9 M&Ms in my hand. I'll have 4 red, 3 blue, and 2 yellow. So imagine that I look at my handful of M&Ms, take out a red one, eat it, then shake up the rest of the M&Ms and pull one at random from the remaining M&Ms without looking. So if I have eaten one red one, then we obviously know that I have 8 M&Ms left in my hand, and that means 3 are red, 3 are blue, and 2 are yellow. So the probability that if I now go to my 8 M&Ms, pick one out, the probability that one is red is 3/8. The probability that the selected one is yellow is 2/8, and the probability that the selected one is blue is 3/8. So since we're conditioning on this knowledge that I ate a red one, we call these probabilities here conditional probabilities. And the way that we write conditional probabilities is with a vertical bar. So we have the vertical bar, and then we have the knowledge, the info, over on the right, and then the event that we're trying to calculate a probability for is over on the left. So if I'm wondering, what's the probability that the selected one is red, given that I already ate a red one, we would write it like this. The probability that the second one is red, given that the first one, the one that I ate, was red. And more generally, when we see something written like this, probability of A vertical bar B, we can read that as the probability that A will occur given that B has already occurred. All right, so if we just think of a very basic example, say you have a friend, this friend is vegetarian, and you're sitting at a restaurant wondering what your friend is going to order. Well, the probability that your friend orders a steak, given that they're vegetarian, is probably 0. So this is one super basic example of conditional probability. All right, so we have this definition of conditional probability. A given B, A will occur given that B has already occurred. It's going to be useful to know how to actually calculate these conditional probabilities. So we saw it in general in the specific case of the M&M example. Now we can write it more generally. So when we have the probability of A given B, the way that we can calculate that is probability of A intersect B in the numerator, and then probability of B in the denominator. So this is going to be true for all events A and B over our sample space, such that the probability of B is not equal to 0, right? Because if we have 0 down in the denominator, we're going to run into a lot of trouble. So we need to have B being an event that can actually happen. All right, so let's use this and look at a couple examples. So in this first example, we have this square dartboard. It's 1 meter by 1 meter, and then we have 2 circles within it. The larger circle has diameter 1 meter, and then the smaller circle has diameter 1/2 meter. Or in other words, the radius is 1/4 of the smaller circle, and then the radius of the larger circle is 1/2. So imagine that every time I throw a dart at this board, it's certain to land inside of the board, but with no discernible pattern. Now I'm wondering, what's the probability that my dart will land in the smaller circle, given that I know it's landed in the bigger circle? So imagine I threw the dart, and then I look away before I see where it lands. And my friend tells me it's in the larger circle, and I'm wondering, I wonder if it's in the smaller circle. What's the probability that it's in the smaller circle, given that it's in the larger circle? What we can do to calculate this probability, because there's no particular pattern here, we can just take the area of the smaller circle and divide it by the area of the larger circle. And of course, area is pi r squared, so we have pi, the radius of the smaller one, squared, divided by pi, radius of the larger one, squared. Once we crunch that out, we get 1/4. So in other words, if I know that my dart has landed in the larger circle, the probability that it's actually in the smaller circle is 1/4. All right, let's look at one more example. Imagine that I have a fair coin and I toss it 3 times. Now I'm going to define 2 events. A is I have more heads than tails, and then B is the first toss is heads. And I'm wondering, what is the probability of A given B? Or in other words, if I know that the first toss is a heads, what's the probability that I got more heads than tails? All right, so first we could write out the sample space. So here's our sample space. We know that there are 8 potential outcomes, and those are all listed here. And then for A, more heads than tails come up, so we just look at our sample space, find all the ones where more heads than tails come up. So we could either have 3 heads or we could have 2 heads. And then B is the first toss is heads, so just select all the things from here where the first entry is an H. All right, so some things that could be useful. First, the probability of A is 4/8, so we won't use that till the end. But the probability of A is 4/8, the probability of B is 4/8 because we have 4 items in each of these sets. And then the probability of A intersect B is 3/8. All right, so we know to calculate the probability of A given B, we need the probability of the intersection divided by the probability of B. So we can just go ahead and plug those things in. We have this, plug them in. 3/8 over 4/8 is 3/4. All right, so in other words, if I know that the first toss was heads, the probability that more heads than tails came up is 3/4. All right, so just to remind you that this conditional probability is different from the probabilities that we talked about in previous videos where we did not have any information to condition on. I'm just going to remind you that the probability of A given B is not equal to the probability of A in general. There are specific cases where this happens, but let's just see. Here is one particular example where probability of A given B is not equal to the probability of A, right? So the probability of A was 4/8, or in other words, 1/2, and the probability of A given B was 3/4. And obviously, these two quantities are not equal. And again, this is because we have the information that B occurred.